Hi, how are you everybody? How are you? Today our class about electric field, electric force, electric work, electric potential. And today the third part. We'll keep going with these physics concepts, and we will explain it very well for everyone till we make sure that everyone understands it fully. Now, what I'm gonna do, I'm gonna just quick review. I'm gonna quick review with you what done last time. Let me just back to my board. Sorry. Okay. Let us see what we done last time. I think that's okay and clear. Okay. Last time we said there's a charge, this negative charge, and this charge has electric field lines, has electric field at any point, and also has an electric potential. The electric potential, which is if you don't watch my video last time, my potential V involved KQ over D. Then we said the V equal E times D, cross product, cross product, E dot D, right? Now, and ED, and I told you one day I will explain this in more detail, the difference between the dot product and cross product. I said what's gonna happen if I'm gonna bring a new charge, Q, from infinity to this point. Then depend on this, we will define something called delta V, change in the voltage, V final minus V initial, V final minus V initial, which is VA minus V infinity. That final is what? A. I need to bring it to A from the infinity. And we define that V at infinity equal what? V at infinity equal to 0. V at infinity equal to 0. Now, also we define from this, you learn this, W equal FD. F dot D dot product, W is a scalar quantity, FD cosine theta. And F equal QE. If you replace F here by QE, ED, look here, if you replace it by QE, F equal Q times E. And ED is delta V. ED is delta V. And delta V, VA, this KQA. Now we have the formula for the work. Work equal WK what? Okay. Now the question I asked last time, example, I put 3 charges, Q1, Q2, Q3. The distance between this and this 4 centimeter, between the 3 centimeter. And the distance from 1 to 3 is 5 centimeter. How much work needed to move a negative two microcolumn from A to B, Then always, guys, always start from what he wants. Always start from what he wants. What he wants the work. Then you define the work. Work equal Q times delta V. Q, VB minus VA. Then I have to find what VB and what VA. What VB, and I stop here. V at B comes from what charges? Charge 1 and charge 2. If you remember from before, when you calculate the voltage, it's not vector quantity. You find V from charge 1 plus V from charge 2 at 3. V from charge 1, V from charge 2 at 3. Which is K Q1 over D1 K Q2 at D2. Now, look how easy this problem can solve if you want. K is the common factor. Q1, how much Q1? Q1 is, did I give you Q1, Q2, Q3? Okay, okay. I will give you a Q1, Q2, Q3. I will give you the values. Q1, I think I gave it last time. No, okay, let me just give you the values of Q1, Q2, Q3. Q1, -3 microcoulomb. Q2, 4 microcoulomb. Q3, 6 microcoulomb. Okay. Then -3, look, in my calculation, I have to take the negative sign in my calculation. When I calculate the voltage, I have to calculate the negative sign. Then this guy, -3, right? Microcoulomb times 10 to the -6 over how much distance from 1 to 3? How much distance from 1 to 3? 5. 5 times 10. 5 times 10 to the -2. Plus Q2, how much? We took K already out. Q2 is 4 times 10 to the -6 over the distance from here is 4 times 10 to the -2. Why -2? Why -2? Because we talk about centimeter. Why -2? Because we talk about negative centimeter. The distance 5 and 2. Okay. Now let us simplify. Let us simplify. This is -3 over 5. Leave K is 9, 10 to the 9. And this -3 over 5 is, if you use your calculator, you divide -3 over 5, -0.6 times 10. This becomes a +2 when you take it. And this guy becomes a +2 when you take it up. -4 plus 1 times 10 to the -4. Now watch here. Watch guys, this -0.6 and this one become 0.4. 9 times 10 to the 9. 0.4 times 10 to the -4 volt. Let me just multiply. And all this for VB. All this for VB, right? Now what we have here guys, 9 times 0.4, 3.6 times 9 plus -4, add the exponent, times 10, 3.6 times 10 to the volt. Now let us find this VB. This VB, let me just put it in a bracket because I need it. Then let me just find VA. He went from VB to V what? A, right? To move from A to B. This A and this B. Now, I want to find the voltage at A. The voltage at A come from, look here, guys. The voltage from A, the voltage on A come from B, come from the charge Q3 and the charge Q2. I'm going to find it on this side. I'm going to find it. The Q at A, I'm going to find it here. Then V at A come from where? Q3 and Q2. V3 plus V2. The same thing, take K out. Q3 over D3. Q2 over D2. And leave K to the end. Dot line here. Q3, 6 times 10 to the -6. And how far Q3 from this? 5 times 10 to the -2. Plus Q2. We're doing this because the voltage is not vector, it's a scalar quantity. That make my problem very simple and very easy. Simple and easy. Now, Q2 is 4 times 10 to the negative 6. I'm copying my numbers here. And from this guy, 3. Negative 2. Why negative 2, guys, again? Because we talk about centimeter. Now, if you use your calculator, leave K, 6 over 5 is 1.2, right? Times 10 to the negative 4. And 4 over 3 is about 1.333 times 10 to the negative 4. You see, guys? Just calculate numbers. Okay. Now, this guy is 9 times 10 to the 9, the K. And these two guys, 1.2, 1.33, is actually repeated decimal. It's 2.53 times 10 to the negative 4. If you multiply 9 times 10 to the 2, 9 times 2.53 is 20.7. No, 9 times 2.53, 9 times 2.53 is 22.77. I like to round to hundredth, and the 9 and negative 4, 10 to the 5 volt. Now I have the two voltages. I have VB and V what? A. This is VA. Okay, now this is my work. He said, the work needed, Q tan delta V, Q VB and minus VA. Now I have both of them. Did you see something? What do you see? What do you see? Now, the charge negative, you keep it negative. The charge negative, you keep it negative, please don't change it. And now let us use our two VB minus VA. How much VB? VB, how much VB? Here VB, 3.6 times 10 to the 5. Both of them 10 to the 5, right? 3.6 times 10 to the 5 minus 22.77 times 10 to the 5. Now, okay, negative 2 times 3. Now let us multiply this and this. And 10 to the 5, 10 to the 5 is a common factor, right? And 10 to the 6, I'm going to do 2 steps. Negative 2, 10 to the negative 6. And this guy, I'm going to do it 3, 2, negative 2, 3 point minus 19, negative 19.17 times 10 to the 5. This comes the parentheses 3.6 minus 22.7. Then you multiply this guy by this guy. Negative and negative is positive. And this is 4, 2, 8, 38, I think 34. 38.34. If you multiply negative and negative, is positive, times 10 to negative 1 joule. Okay. Let us see this answer. This is my work needed. This is the work needed to bring a charge, a negative charge, to move a charge from negative 2 here, which is here positive, to here. Let's see. Here, make the charge, the voltage here, you're going to move negative 2 from here, which is attractive force, to here, right? then you have to work. You have to do a positive work to move. Because look here, this is negative and this positive. You have to do a positive work. You have to do a work to do this because you're moving attractive. This negative 2 microcoulomb and this positive. From A to B, and this is negative, you have to attract, repulsive, negative and negative 3, then they are already moving. Then the work is going to be just directly, just slide down, like you're going incline, Now, if I need to calculate the change in potential energy, just if he asks me how much change and potential energy. What I have to do? Delta U. Look, work equal negative delta U. Wow, that's all what you have to do. Negative, let me just make it uppercase. Work equal negative delta U. Then delta U is negative. Okay, let us do it like this. Negative work, and the work is what? Negative Q. The work itself, Q delta what? V. Right? Then, look here, delta U. Then delta U, because here, work equal negative delta U, or delta U equal negative the work, and the work equal Q delta V. And already we calculate the work done here. Then delta U, change in the potential energy, is going to be negative 338.34 38.34 joule. Negative. What's the meaning of this negative sign in here? If you go there, the potential energy of this object, as I said before, we have a negative, right? And the object goes down, and that means it's decreasing from low voltage to high what? Voltage. From low voltage, look here, VB is 3.6, right? And VA is how much? From the high voltage, because there's two negatives, to the high voltage. It remains like high when you are inclined. From high voltage, VB, right? Low to where? VB minus what? VA. From A, I need to move it from A to B. From high to where? From high, which is how much? 22, to low, which is 3.6. From high, which is 22.7, to low, which is what? 3.6. From high to low, that means the potential is dropping, it decreases, right? There is change in the potential energy. Guys, thank you and have a nice day. Don't forget, as before, to subscribe and like, and we will keep going with more problems. We'll practice more problems. We'll practice more problems. And next time, I will bring a lot of problems to solve it, different cases, different situations about potential, forces, electric field in general, about all this topic. I'm going to spend about 2-3 classes just solving a problem about forces, electric field, work, potential energy. Wait for me, and thanks for having me.